out. I'm seeing majority 4, 5, and 3. So we'll do those. And 3 and 4 can be done on desmos, and then we'll talk about 5. Okay, so for number 3, if I were to plot the points -4, 4, and 8, -2. Then I'm looking for the line that goes through this, so I can type in y equals mx plus b. Add in all the sliders. Figure out what my slope is by counting. So going down 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So down 6 to the right 12 would give us -1/2. And then I would move the b until it goes through those 2 points, which is at 2. So our equation would be y equals -1/2 x plus 2. So as a reminder, if you are not using desmos, you should be trying every problem that you can into desmos as your SOL is fast approaching, and you need to be able to do this. I'll rewrite that on the SOL on the short grade sheet. Questions on that one? Yes.
Do we have to use desmos on the SOL?
You will not be given calculators.
But if we
You could you could do it by hand. Yes, but I would double check it in desmos. And then for number 4, you can also put that into desmos, but change all the n's to x's. You may have to zoom out. And then that would give us n equals -17. Make sure you're putting use desmos on those if that's what you did. Questions on either of those? Yes. I'm only showing things in desmos because that's also what you should be doing. And then for question 5, we're looking for which 2 steps did he make a mistake. So from step 1 to step 2, he subtracted 1 to both sides. That's not what we usually do, but that is an okay step. Step 2 to step 3, distributed the -4, so -4x plus 28, that's fine. Step 3 to step 4, subtracted 28 to the other side to get -32, so that's fine. And then from step 4 to step 5, when he divided, he did not change the sign. So that was the correct answer. If you had put this into desmos, you would see that it graphs this, but the other way. And that would show you that is what's wrong. Questions on that?
Do we have to write what he did wrong?
No, you can write step 4, step 5. Alright, go ahead and make sure your names are on, and then we're going to get into what we're actually doing today. So I'm not going to solve all of these unless we ask for it, yes.
What is one unit and our last unit?
Okay, so in our different factoring methods, we have GCF. So if you can find something that everything has in common, you could divide something out of that. Of all of these, this one does have a GCF, but it also is something else. So we'll come back to that. But this one also has a GCF. This could be any amount of terms. What would the GCF of this be? 5. What else?
5x2, y2.
And when we divide that out, what's left?
2x. 5.
So that's your GCF. That can be used for any amount of terms. You could also find the number in your calculator, math, number, GCD, but you can only do that 2 at a time. Or in desmos, you could do the GCD, any of them. If you have, I'm jumping around, just 2 terms, your binomial, that's either GCF or difference of squares. Does this have a GCF? No. So difference of squares, when you have 2 sets of factors and you're looking for what times what will give you 4,
2x.
and then what times what will give you x squared would be x. Put a plus and a minus, and then what times what will give you 25. Where you split that up and both sides, both factors are identical except one's a plus, one's a minus. And then we have our trinomials, where a equals 1, and that's where we're looking for 2 numbers that multiply to be c, whatever this number is, but adds to be b. We're not going to actually do that one, but I do want you to write at least that. And then we will do 3. 5 was supposed to be a one with 4 terms, but I'm not going to make one up because it may not work out. But this one would be a trinomial where a does not equal 1. And we're not going to do that entirely, but this is where you would multiply a and c, figure out what that is, and then whatever that is has to also add to be b. And then after you get that, you change the middle term to those 2 numbers and then factor by grouping. James, you were going to ask something.
I was just going to ask, is 1 negative 5 and 30?
Is the other way around. That's supposed to say grouping. The board's not letting me write. And then if we had 4 terms, so part of a doesn't equal 1 is grouping, but if we just have 4 terms, that is grouping, where you split the middle and find the GCF of both sides. We're going to get practice with doing the different types of factoring again in a moment, but I just wanted us to review what the different types look like because we'll have to know those different types in a moment. Go on to not the back of that page, but stick to this page. here we are dividing different polynomials, polynomials, by monomials, one term. And these can be done one of two ways. By factoring out the GCF or by separating. I'm going to show you both. So in number 1, if I separate this, I'm going to take each term and put it over 4. And then just divide those. What would that give us? 2t plus 3. And that would be our answer. The other way you could do this is to use the GCF of the numerator. So if we look for what do these have in common? 4. And if I divided 4 out of both of these, what's left?
2t plus 3.
But we still have to put the denominator there. Usually when you factor out a GCF, whatever that denominator is should be the same. Sometimes it will be different. We'll talk about that in a moment. But then if they're the same, you can cancel out your like factors to get that final answer. So you have a choice. If you like the GCF method, do that. If you like the separating method, do that. We'll do another one where we do both, and then after that we'll do I'll let you guys choose. In number 2, we'll do GCF first. What do these have in common? 1t. And if we divide that out, what's left? 2t minus 9. Don't forget about that t that you were dividing by. Those are like terms, common factors, sure. So divide that out, and then our final answer is just 2t minus 9. I'm going to go back and separate it just to show you it works the same way. So after this one, you guys can choose which one you do. Let's skip to number 5. Do we have questions so far? For number 5, do we want to do GCF or separating? Separating, okay. So you have 8a squared b over ab plus 3ab squared over ab. Divide each piece. What's left?
8a plus 3b.
And that would be our final answer. I meant to say this. This is going back to our polynomial operations from our exponents, but just the dividing piece of it. So all of our exponent rules can be like, Okay, let's do 6 and then we'll do 8. 6, do we want to do by separating or GCF?
Separating.
Okay. So go ahead and start writing that, separate it out. What would each piece give us?
2t squared plus 9t minus 5. Okay. Last one on this page. Number 8, separating or GCF? Separating.
Okay. So go ahead and write that out as separating. If you want to do GCF instead, go for it.
And let's divide each piece. What will we get?
2A1
4 plus
5A
5a what?
2, 3, 2.
5a squared b squared plus
Nothing.
1. Any questions on how we divide polynomials by monomials? Yes.
I have a question about this test. We're gonna have a test on this.
Correct.
Are we gonna have to know how to do GCF and separating?
You'll have to choose. You can choose. You won't have to do both. Okay. Somewhere where you have space, I want you to write this down. You're just writing this down. Okay? So this one can be done using both methods, but I'm going to show you what happens with both. Right. Let's say we were doing GCF with this. What would the GCF of this numerator be?
3.
What else?
X, Y.
And then we're going to divide that out of everything. There, what would be left?
Y, 2.
You missed an X. So it'd be X, Y, and then
4.
to the fourth. Minus,
3.
plus,
Minus 1.
say that again.
Minus X 2, Y.
Not 9 here close, but it is X squared Y.
8.
So normally when we do the GCF, they're the same, but in this case they're not. This will tell you that you either need to stop, start over, and start with separating, or continue along the path that I'm about to show you. So if you see something where they are not the same, you can't just cancel them out. We're going to rewrite this GCF over the denominator. And put everything in parentheses next to it. We're going to just simplify the fraction part. What would that simplify to be? Three divided by 3 would give us 1. We're subtracting our exponents. What were our exponents? What exponents would we have left? 1. It would be 1x, but it wouldn't be in the numerator. And we'd have 2 y's, but again, not in the numerator. How would we write that? 1 over xy squared. Your negative exponents come into play because you subtracted it. Would have gotten negative exponents that would have changed. And then rewrite your everything in parentheses. And then you would need to distribute your fraction to everything inside the parentheses. So I'm just going to write it as is first, and then we can simplify. And then once you have that, we'll simplify. What would each piece give us?
X.
The x would cancel here.
Y squared.
Y squared. Would this simplify at all? No. So it would stay the same. Plus,
8 over 1.
we missed the x there.
8x.
Over 1.
There we go. And that would be our final answer. So while it can be done using GCF, it's not ideal, / if you remember how to do it, it would be fine. But you have to remember to bring the fraction over, simplify that, and then multiply it back. That's the end of
Yeah, this is the fraction.
Is that what you're going to ask?
Can you, no, I was gonna ask if you can do this and separate.
Yeah, that's what we're going to do next.
Do you get a different answer? for
No.
separating? Does it look the exact same?
It looks the exact same. It's just shorter.
Is the separating, like when you do it and for the final answer, is it also supposed to have fractions?
So I'm going to rewrite the problem, but separate it. Separate it. 3x squared y squared. So if we separate it and we divide, what would be left here?
1y to the second
1y squared.
Or just y squared
minus 3
3 over x y squared.
plus
8x over. Wait, why is that so easy?
So if you see something like that, if you already like separating, just do separating anyway. But if you are one that likes GCF, either be careful while you're doing it or switch to separating. Questions there? Alright, now let's move on to go back to this page. Because now we're going to divide polynomials by binomials. And in order to do this, we have to factor the numerator and then do that, whatever process that is, and then cancel any like factors. If you want to try and adjust so that that's on your face or move to the other seat, you can. Alright, so think about all of our different ways of factoring. And number one, we have a trinomial. There are only two types. A equals 1 and A does not equal 1. Which one is this? A equals 1. Because there's an invisible 1 in front of this. So that means we're looking for two numbers that multiply to be 6, that add to be 5. What two numbers would that be?
3 and 2.
2 and 3. So I'm going to go right into my factors. X plus 2, x plus 3. And rewrite that you were dividing. Cancel out your like equals 1, that should be fairly easy. Hardest part would be finding your factors. Do one more.
Again, we have another trinomial. Is this a equals 1 or a doesn't equal 1? A
Doesn't equal
it equals 1. So then we're looking for two numbers that multiply to be 27 but add to be 12. 9 and 3. X plus 9, x plus 3. When you're doing this, a hint for the a equals 1, one of the numbers is going to be whatever is in the denominator. So then when we cancel out our like factors, what's left?
X.
Make sure you are actually canceling out your like factors. Okay, yes.
So every time a equals 1, is there going to be a factor?
In all of these, there'll be a factor that cancels out, but in this one, the process is a little easier. Okay, I'm going to skip 3, go on to 4. This is another trinomial. Is it a equals 1 or a does not equal 1?
It is not equal.
It does not equal 1. So in that process, we are multiplying 6 and 5 to get, okay, and we're looking for two numbers that multiply to be 30 but add to be 13. 10 and 30. So we are not setting it up like we just were. This is where we rewrite this into 4 terms. And as you rewrite it, you still have to show that you're dividing in each step. We can't lose that denominator. It doesn't magically disappear. So then from there, you're going to split the middle and find the GCF of the first two. I didn't think that pass actually went through this. What would the GCF of these first two be? 2x, leaving us with 3x plus 5. We divide GCF out of the last two, what would that be? 1. If nothing else, always 1. And then again, rewrite that we're dividing. Make sure we're writing this down, guys. And then don't cancel out your like factors yet. Rewrite them into final factors. We have 2x plus 1 and 3x plus 5. And then if we cancel out our like factors, what's left?
3x
3x
plus 5.
plus 5.
So your a does not equal 1 has more steps. Questions there. Do we want to do 5? Okay, I saw some yeses.
Can we do 6?
We are going to do 6 and 7. So this is another trinomial. Which type? A does not equal 1. Now, do you have to write that off to the side? No, but if it helps you recognize, okay, this is how I'm going to factor it, you can do that. So then multiply 4 and 5 to get 20, and we're looking for two numbers that multiply to be 20 but add to be negative 12.
Negative 10.
Negative 10, negative 2. So we have 4x squared minus 10x minus 2x plus 5, or if you switch them, that's okay. All over 2x minus 1. And then split that down the middle. What could we divide out of those first two? 2x. What would be left?
2x minus 5.
What could we divide out of the last two?
1.
Positive 1 or negative 1?
-1. Leaving us with 2x minus 5. And then rewrite your final factors. And that would be our final answer. Make sure you cancel out your like factors. Alright. In number 6, we have 4 terms. How would we factor that?
Splitting it down in
Yes, what is the name of this type of factor? That's a trinomial.
Do we have to know the name?
No, but we just talked about it. I was trying to see if you guys were paying attention.
GCF. Factor.
We just talked about it. Like, we just wrote it down.
Polynomial division.
We didn't write that down. That was already done.
A equals 1.
That's for trinomials. It does start with a G. It's not GCF.
GCD. Oh my god. Are you for real?
What would the GCF be of the first two?
1 m squared.
1m squared, or just m squared. What would be left?
3m
4m minus 1. What would we divide out of the last two? N plus n. What would be left?
4m
Minus 1. And then just rewrite your final factors. So then our final answer is
4m minus 1.
how would we factor number 7?
Split it down the middle. No. We would have to do the multiplication to find it.
Also no.
But there's not one in the middle.
Correct. It's not one in the middle. It's not a trinomial. It's a binomial. How can we factor a binomial?
Cancel?
No. No. Yes, we are going to separate it, but how?
Grouping.
No, it's not 4 terms. Yes. Difference of squares. M plus 3, M minus 3.
Oh, that's so smart. Oh, so you would like put apart.
You're using your difference of squares. Looking for what times what will give you M squared and what times what will give you 9. So our final answer would be yes. Difference of squares. Or difference of perfect squares either.
Do we have to know the names of these? Or do we just
It
not know how to
helps.
do it?
It would help you recognize, put a factoring name to this is how I do it. Do we have any questions on how to divide polynomials by binomials? Okay. Turn to the SOL page, and if you don't have an iPad, go grab one. then once you finish that, start typing each of the answers into another line. So I mentioned this when we did the SOL practice, but now that we actually know how to do it. So you can always do this algebraically, but to check yourself in Desmos, put in the original, and then if you put in the answer choices, if it's multiple choice, only one of them is going to overlap this original shape at the x-axis.
It's 4x plus 5.
And that would be one of the factors. Now you could also check yourself, if it wasn't multiple choice, you could solve it and then put in your factors and see do they overlap that shape at the x-axis. And if they do, you know you did that right. I'm going to go back to the number 7 we just did. And I'm going to type in that whole thing, except instead of m's, use x's, because Desmos doesn't like other variables. And anytime you have a polynomial division problem, if you put that into Desmos, you're going to get a line. That line is going to tell you whatever your answer is. You could read the line by just finding the y-intercept, finding the slope. So I see the y-intercept is at -3. The slope is going up 1 to the right 1. So if I were to type in y equals x minus 3, they would overlap. But I could also just get rid of the y equals. And that would tell me what my factor is. Or what my remaining factor is. Those are basically how you would check. It works the same way in the calculator. Does anyone want to see that in the calculator? Do we have any questions on how to check yourself in Desmos or the calculator? Do you have a question? For the SOL practice? The same thing. So of all of these, there's only one that crosses that original shape at the x-axis. And that would be your answer. So anytime you see something without x's, in Desmos put x's, use the answer choices or put in your answer choices and see if they match. Do we have any other questions specifically or in general? Okay. So for the remainder of class, you could be working on a multitude of things. I'm going to put out the quiz for this that is practice, it's not for a grade. So if you wanted to see what the test, a little snippet of the test might look like to practice that, you could do that. You could work on more questions in this packet of notes. You could work on Delta Math that's due today, or past Delta Math.
from last week, 2 weeks ago. You could work on your SOL practice that's due on Thursday. Your math gap packet is now just SOL practice, so you could work through that, bring it up, just check it individually if you want to do that, or JLabs. So you have a bunch of different things you could be working on. Use this time wisely. We can work together. I'll unlock the iPads.